In this video, we'll be looking at our heat budget for Earth, and we'll also be discussing climate change. Let's get started. Long-term heat budget on Earth. When you consider how the Earth's temperature is changing, we can see that there is a trend of increasing temperature for our Earth. The line in this graph is never constant and never straight. But over the past 30 years, the Earth has been warmer than it has been in the past. Of course, there's some controversy as to why, so let's deal with the facts first. 10,000 years ago, the last ice age ended. An ice age is said to occur when glaciers, which are typically found at the North and South Poles, advance to middle latitudes. Now, we haven't talked about glaciers in detail yet, but glaciers are large sheets of ice that can flow between mountains or over entire continents. Interestingly enough, shifts in the balance of heat of Earth's global climate can produce long periods of cooling just as easily as it can produce long periods of warming like we see today. Using ice core data, the last ice age occurred 10,000 years ago. The Earth has experienced at least 5 major ice ages in its past history. All 5 indicate a time of major cooling and colder than average temperatures. So what could cause an ice age? Well, changes in the sun's energy could do it. Sunspots follow an 11-year cycle. When there are large numbers of sunspots, the sun emits more electromagnetic energy and more insolation. If there are low numbers of sunspots, then the opposite occurs. So this is one potential reason why the Earth may have been in an ice age in the past, because of the sunspot cycle. Another reason could be Earth's positioning. Now, we learned that Earth has a tilt of 23.5 degrees, but over periods of thousands of years, that tilt can change. It's only a few degrees, but the impact would cause seasons to be stronger or weaker depending on how much that change was. Also, over thousands of years, the eccentricity of Earth's orbit has changed. If these two events were to occur at the same time, an ice age could certainly be the result. And then there are volcanic eruptions. When a volcano erupts, aerosols such as volcanic ash and sulfur compounds are propelled into the stratosphere and stay there for months or years. Similar to volcanic eruptions, collisions with asteroids and large meteors can also lead to an increased composition of aerosols in the atmosphere. And then there's carbon dioxide, a greenhouse gas. Carbon dioxide has always been in low amounts in our atmosphere relative to the other major gases, but its amount has always fluctuated. Look at this graph and look carefully at the amount of carbon dioxide that seems to go up and down in the past. Human beings were not present 300,000 years ago when levels were very high. The changing amount of carbon dioxide may have helped the Earth cool down in the past. Having less greenhouse gases could have caused an ice age. But I want to shift our focus now to the other end of this graph to discuss the current warming trend, which we call global warming. Obviously, this is not a good sign. When the carbon dioxide levels are higher than they have ever been, that's an indicator that human beings have had an impact on the Earth. Let's uncover some of the evidence that supports this. Our first piece of evidence is from ice cores. Analyzing the bubbles in ice cores taken from Antarctica and Greenland show how much carbon dioxide was in the atmosphere before and how much is it in the atmosphere now. Think of an ice core as a time capsule. Ice melts and freezes over and over again, capturing some air in it when that happens. Each year, new ice freezes over old ice, and the ice grows vertically. This forms layers. Layers towards the bottom are older than layers on the top. So this is a very reliable source of data that can give us a history of ice on the planet. Our next piece of evidence occurs at 56,000 feet. This is Mauna Loa. It's on the largest island of Hawaii, and it's Earth's biggest volcano. It's erupted 33 times since 1843. Positioned on Mauna Loa is the Mauna Loa Observatory. It's an atmospheric research facility that has been continuously monitoring and collecting data related to atmospheric change since the 1950s. It sits at 11,000 feet, and the air here is undisturbed and minimally influenced by vegetation and human activity. So the data collected here supports a dramatic increase in carbon dioxide in our atmosphere over the last 50 years. Like the ice cores, this is a reliable data set, and it points to increase in carbon dioxide as the reasons, or one of the reasons, why the warming trend is occurring that we're seeing now. But is it? We said sunspots, changes to Earth's tilt and eccentricity, volcanic eruptions, meteors colliding with Earth, they can all influence Earth's heat budget. But there is something else that can influence how hot it is on Earth. It normally occurs every 2 to 10 years when the normally cold waters of the eastern Pacific Ocean off western South America are replaced with warmer waters. This can create a global increase in Earth's temperature. This is also known as El Nino. So let's talk about how El Nino occurs. So El Nino can affect weather around the world, causing droughts, floods, heat waves, long periods of cold temperatures for some seasons, long periods of warm temperatures for others. Let's talk about what normally happens in the Pacific Ocean. Trade winds are blowing from east to west, and these winds are blowing warm water that it's near the surface to the western side. This warm water is piling up off the coast of Eastern Asia. At the same time, cold water is pulled up to replace this warm surface water that has been moved off the coast of Western, Central, and South Americas. This process is called upwelling. This creates a temperature difference across the tropical Pacific. Colder water off South America, warmer water off Eastern Asia. The warmer water adds extra heat to the air and causes the air to rise quickly and with more force. The result is unstable weather conditions in the atmosphere, which really equates to more rain and more clouds. Because of this, a global circulation is set up, with warm, moist air rising in the west and cool, dry air sinking in the east. Again, these are normal conditions. So when El Nino begins, it slows the changes in the ocean by weakening the trade winds and reverses this mechanism. Weaker trade winds don't push the warm water west, and then upwelling doesn't occur. As a result, rainfall patterns and wind patterns shift. This can affect global rainfall and temperatures in this area as well as globally. So that natural mechanism is no longer functioning. And that puts an end to the circulation of warm and cold water in the tropical Pacific. The extra heat at the surface of the tropical Pacific is released into the atmosphere during El Nino events. This can temporarily cause global temperatures to rise. El Nino years are typically associated with the warmest years on record. Looking at this bar graph, the bars demonstrate the relationship between El Nino and warmer Earth temperatures. What's not well understood is which really controls the other. Is it that the Earth is already warm, so El Nino only adds more heat? Or is it that the Earth is only warm because of those El Nino events? There's definitely a correlation between the two, because in this graph, most of the red bars have seemed to occur in the last 30 years when the Earth's temperature has been much higher. What's undeniable is that human beings continue to have an impact on their Earth. Pollution, overpopulation, and agriculture are pushing Earth systems to the limit. Climate change and global warming may have happened if human beings were not here, but it's safe to conclude that our industrialization has accelerated the process. As the Earth's climate changes, so will familiar features on its surface. Weather patterns will change, storms will surge and grow stronger. And if humans aren't able to reverse the process or slow it down, there's always Mars. That's it for now, and thanks for watching.